Quadratic functions review. It says that somewhere here. So what I'm going to do here is I'm going to work through this worksheet. So if you're home and it's the night before the test and you're not sure about one of these and all you're seeing is the answers on the answer sheet, then here are fully worked out solutions. Okay, so question 1. For the function y equals negative 1/2 x plus 1 quantity squared plus 4. What do we know? Well, we know it's vertically stretched by a factor of 1/2, right? I'm going to describe the transformations. Vertically stretched by a factor of 1/2, which results in a vertical compression. Okay, again, we say results in a compression or expansion. We don't use compression or expansion. We say vertically stretched. It's then reflected in the x-axis, so now it opens down. It is horizontally translated 1 unit left and vertically translated up 4 units. So what's that do to the vertex? 1 left, negative 1, up 4. It's the equation of the axis of symmetry. That goes through the x-coordinate of the vertex. X equals negative 1. And I think that was generally well done, because a lot of times people will just write the negative 1, but it's an equation, so it's got to be equal. State the range. It opens down. It has a maximum. The maximum is the y-coordinate of the vertex. So it's the set of all y's such that y is less than or equal to 4. Algebraically determine the x-intercepts. Oh my god, we need some work on this one, so let's go through this. X-intercept, it's not asking for the y-intercept yet. That's down here. State the y-intercept. X-intercepts, what do? We set y equal to 0. Now, watch the procedure here. 0 is equal to negative 1/2 x plus 1 squared plus 4, right? Algebraically determine. Determine means show your work. Okay, what we want to do is I want to get the x plus 1 squared by itself. To do that, let's start by subtracting 4 from both sides. I want to get the x plus 1 squared by itself. Let's get rid of this negative 1/2. How am I going to do that? I could divide by negative 1/2, but I'm going to multiply by negative 2. Negative 4 times negative 2 is 8. Negative 2 times negative 1/2 is 1. So now we have isolated the x plus 1 squared. Next step, square root both sides. Okay, we never, ever, ever, ever expand this. And if we do, we certainly do it right. Remember, there will be 3 terms here if you expand this, but we never expand it. So plus or minus root 8 is equal to x plus 1, which means that x is equal, to get the x by itself, subtract 1, negative 1 plus or minus root 8. That's what gives us the 2x intercept. Since we know this opens down and it's above the axis, it must have 2x intercepts. And last step, root 8 is 2 root 2. So you'll have to go on your own and review mixed radicals to simplified radicals to mixed radicals. I'm sure you can find a million YouTube videos on that, or go to Khan Academy and look up radicals and simplifying radicals. Negative 1 plus or minus 2 root 2. State the y-intercept. Okay, this is state. Just give me the y-intercept. Okay, how do you do that? Well, a little more difficult. In this form, it's not just the 4, right? Y-intercept, x is 0. Put a 0 in here. 0 plus 1 is 1. 1 squared is 1. Times negative 1/2. 1 times negative 1/2 is negative 1/2. Plus 4 will be 3.5. Okay? We don't like to say that way, though. So we say it as negative 7/2. Okay? Negative 3.5. But we like our fractions improper, not mixed, not decimal, right? This is exact, and if it wasn't a half, if it was a third or something, you couldn't say negative 3 1/3, right? You would have to write it as a fraction. Okay, and F down here, right, just off the page, says graph this, labeling at least 5 points. And I think really what it means is to show 5 points. Okay, let's start with the vertex. Negative 1, 4. There's my vertex. Okay, that's 1 point. I got to show 4 other points. All right, normally I would move over 1, down 1, right? Down because of the negative, but it's multiplied by a half, so I could go down a half, but that's kind of guessing. So let's go over 2. Normally I would go down 4. Half of 4 is 2. I'm going to go down 2. By symmetry, move over 2 to the left. Go down 2, right? Nice even number. If you go over 3, you'd go down 9. Half of 9 is 4.5, again with the halves. So how about if we go over 4? 1, 2, 3, 4. 4 squared is 16. Going down, I would go down 16. Half of 16 is 8. Let's go down 8. From positive 4, we will go down to negative 4. There's a point. And by symmetry, 1, 2, 3, 4. So I have labeled, or actually shown, I think we should have said showing 5 points, right? Maybe labeling the vertex. This is what I would mean by label, which is put the coordinates on there, okay? If I said label the x-intercepts, which we did. Well, first let's draw this out. Now, I'm not so great with the tablet, so my sketch is probably... it's not so bad. Okay, got bad at the end. But arrows, must have arrows. This goes on forever. It's not an application. In an application, then, we may have a restricted domain and range. Arrow. Okay, some of the stuff it doesn't ask for, right? It doesn't ask for me to label the x-intercepts. And, negative 1 plus 2 root 2. 2 root 2, root 8. Root 8, what is that? Well, it's close to 3. Root 9 is 3, so it's over 2, so I'd have like negative 1 minus 2 be negative 3 something. That's almost reasonably accurate. If I had said label this, I would expect you label the intercepts, you do this, and go negative 1 minus 2 root 2. And go over here and go negative 1 plus 2 root 2, right? That's labeling. Label the y-intercept 3.5, right? Here it was here. There's the y-intercept, negative 7 halves. Okay, so if your drawing's as bad as mine, it's all shaky and that's why we have these 5 points on here, right? Labeling 5 points is because those are exact points on the parabola. Okay, let's move down. Oh, what else could we have done here? Which isn't asked for, but the domain, right? The domain is the set of all x such that x belongs to the reals. We were asked for the range. Y-intercepts, I could have asked for the axis of symmetry. Okay, there's the axis of symmetry drawn. When you do that, make it an actual line. Don't just, kind of label it or do something. Make an actual line that somebody can actually see. And if we're labeling it, and I'm looking for my cursor here, which I'm moving down, let's label x equals negative 1, right? That's the equation of the axis of symmetry. And I really think that's about all we could have asked you for on this particular thing. We got vertex, we got x-intercepts, we got y-intercepts. We could say how many x-intercepts. Could have asked you to describe the transformations, right? Again, in order. Stretches first. Vertically stretched by a factor of 1/2. Reflected in the x-axis. Horizontal translation left 1, vertical translation up 4. That's the order. Stretches, reflections, transformations. Remember it and get it right. Number 2. The graph of y equals x squared was transformed to y equals negative 2, x minus 10, quantity squared, minus 5. Where are we? Here we are. The point negative 4, 16 lies on the graph of y equals x squared. Determine the image point, the coordinates of its image point after the transformation. Okay, let's trace this one step at a time. First, write down what is going on here, right? Number 1, we have a vertical stretch by a factor of 2. We have the minus sign. Number 2, reflection. You must stretch first, then reflect. Reflection about x axis. Next, I usually go horizontal first. It doesn't matter at this point though. I'm going to go horizontal translation, right 10. So over here, 3 HT, right 10. And last, a vertical translation, down 5. When you describe transformations, you tell me what kind, horizontal or vertical. Then you say which way, right and how much, 10, down 5. And you can do it the other way. You could say horizontal translation, 10 units right. Vertical translation, 5 units down. What must I see? I really want to know what kind of translation, and then I want you to tell me two things, which way, how much, or how much, which way. All right, well, what does any of that have to do with this? It means I start with negative 416. When I vertically stretch it by a factor of 2, that is going to change the y value. Instead of 16, it's going to be twice that. So it's 32. When I reflect it about the axis, this will go negative 4, and now instead of being 32 units above the axis, it's reflected, it's 32 units below the axis. Move it 10 units to the right. From negative 4, let's go right 10. That will take me to positive 6. And this will stay. Some people will do this all at once. And down 5. So that's 6, and this will be negative 37. Okay, now some people will go from here and do the 2 at once and say go right 10 to positive 6 and down 5, negative 37. Since the order of these doesn't matter, right, but the order of these does matter. Stretch it first by a factor of 2. That affects the y value. Then reflect, and then do your translations. Okay, next, number 3. A bridge spans a horizontal distance of 40 meters and has a parabolic arch. 1 meter from the end of the bridge, the arch is 1.95 meters high. Determine an equation, very important, an equation that represents the parabolic arch if one end of the arch is at 0, 0. Okay, always, always, always draw a diagram. Here is my parabolic arch. One end is at 0, 0. So I'm going to place my axes. Okay, we need a frame of reference. This is 0, 0. It spans 40 meters horizontally. Then this will be 40, 0. How high is it? It doesn't say. But it says 1 meter from the end of the bridge. The bridge is 1.95 meters high. Now 1 meter can be either 1 meter from this end or 1 meter from this end. 1 meter from 40 will be 39 and 1.95, and 1 meter from this end will be 1 meter horizontally and 1.95 vertically. Okay, what do we have? Do we have PQ? Well, okay, wait, we have P. We don't have it, we have to get it, right? The vertex is going to be halfway between 0 and 40. So it's at 20, comma, how high? Don't know. So we're going to go with the Q. I do not know Q. And what else? I do not know A, right? Remember, A is the shape. I know A is negative, but it'll work out negative. So how are we going to do this, right? Well, we have 2 points that we can use, right? We can use 0, 0 as a point. We can use 39, 1.95 as a point. We can use 1, 1.95, or 40, 0. So what am I doing? Well, I say I know that the vertex form of the equation of a quadratic function is this. I know P, right? We had enough information. I have an X and a Y. So let's use, how about 0, 0. When Y is 0, I don't know A. X is 0, minus 20 squared, and I don't know Q. Simplify. 0 is equal to negative 20 squared is 400. So 400A plus Q. Okay, what else do we have? Well, I could use 40, 0, right? But if I do, I put a 40 in here, we're just going to end up with the exact same equation. Since I'll go 40 minus 20 is positive 20 squared, so that's not going to work. I'm going to use one of these other points. Okay, one of the points is 1.95. So when y is 1.95, that's equal to a. Let's go with the 39 because that'll make this a positive, right? Although it really makes no difference because we're squaring. So x is 39 minus 20 squared plus q. Still don't know q, right? We're doing this. We're going to get a system of equations. 1.95 is, okay, we have 19 squared. And so I'm just digging out a calculator here. 19 squared. I'm still digging out a calculator here. 19 times 19 equals 361. Okay, so 39 minus 20 is 19 squared. 361a plus q. I now have two equations. Call this equation 1, equation 2. They both have a q in them, just a q, right? So that means that I can subtract one from the other. So we'll take equation 1, and from it, we will subtract equation 2. Okay, let's see what we get. Okay, so let's go over here, and we will solve that system. So 4, nice 4. So I can fix the 4. Oh, I was at the top of the tablet. 400a plus q equals 0. 361a plus q equals 1.95. Okay, let's subtract. This will give me 39a, q's are gone, equals negative 1.95. So a is equal to negative 0.05. And since this is an application, you know, we can stick with that. That would also be like 5 over 100. I found a. Let's find q. We'll just put the a back up in here. So we'll go 400. So 400 times negative 0.05 plus q is equal to 0. Negative 20 plus q is 0, and q is 20. So q the answer. Final answer is y equals negative 0.05 bracket x minus 20 squared plus 20. Huh, interesting. So now we know that over here it really is 20 high. It's 20 meters along. It's also 20 meters high. So anyways, that is our equation for this, right? So what did we do? We solved a system. We had the p, but we didn't have the q, we didn't have the a. We didn't know the shape. All right, let's move on. Down, over, go down. Where are you? Gotta find my cursor here. Here we go. Express negative 3x squared plus 5x plus 4 in vertex form. Complete the square. I'll do this both methods, right? And I'll do one here on the left. So negative 3, got to factor that out, x squared. Divide this by negative 3, it'll be minus 5/3 x, leave some space, and then plus 4. Okay, y equals negative 3. I need the binomial here. Half of 5/3 is 5/6. So minus 5/6 squared. You square 5 over 6, you get 25 over 36. You add it on, plus 25 over 36. So I ask you, what's different from this line to this line? And you'll say, you added 25 over 36. And I'll say, no, I didn't, because of the negative 3. So negative 3 times this, the 3 goes into the 36, gives me negative 25 over 12. So what did I do? I did not add 25 over 36. I subtracted 25 over 12. So out here, I'm going to add 25 over 12. The 4. The 4 is 48 over 12. So now I've got 48 over 12 plus 25 over 12, which gives me plus 73 over 12. Okay, that's one way. Second way, if you like to do it line by line. Starts out the same, negative 3, right? We have got to get rid of that. This must be an x squared. Minus 5/3 x, leave space, plus 4, exact same as this line. Okay, let's come down here. y equals negative 3 x squared minus 5/3 x. Half of 5/3 is 5/6. Squared is plus 25 over 36. Also, in the brackets, then, we subtract 25 over 36 plus 4. Okay, so this line is the same as this because this adds up to 0. Now, we need to get rid of this. We're going to take it out of the brackets. We're going to do that by multiplying by negative 3. Negative 3. I only want 3 terms in here, right, because it's a trinomial square. Plus 25 over 36. Negative 3 times this will be plus 25 over 12 plus 4. Last step, negative 3. The factorization of this, it's actually already done, right? We did it as soon as we got half of that. X minus 5/6 squared. And then these combine as they did over there. This will be 48 over 12. Need that common denominator, so plus 73 over 12. Nuts and bolts. Sells one type of bolt for 90 cents. At this price, the company sells 10,000 bolts per month. Market research indicates that for every 10-cent increase in price, the company will sell 500 fewer bolts. Determine the price of a bolt that will maximize revenue. Revenue, how much money you bring in. Revenue is the money you bring in. So it's how much you sell it for times how many items you sell. So it's the cost times the number of items. Okay, we need some variables, right? Let x be. Okay, so we need to know how many price increases are we going to make. So it's going to be the number of 10-cent price increases. And R will be the revenue, right? That's the thing we're going to maximize. R be the revenue. Okay, what's revenue? Revenue is the cost of the items. Okay, so that's 0.90. They're 90 cents plus 10 cents for every price increase, so plus 0.1x. That's the cost of the item. The number of items, well, how many do we sell? We sell 10,000 bolts per month. So 10,000, but we'll sell 500 fewer for every price increase. Okay, so this will be the new price. One price increase will give me 90 cents plus 10 cents, which is $1. And I will sell 500 fewer bolts or 9,500 bolts. And this makes sense in that context, right? Sometimes you need to look at your equations and say, do they make sense in the context of the question? If I have 5 price increases, well, this will be 50, 90 plus 50 is $1.40. 5 10-cent price increases will take me from 90 to 140. And I will sell 2,500 fewer bolts, 500 times 5. Okay, this is what we want to maximize. So what do? Well, we multiply this out. We use FOIL. So I've got 9,000, 90 times 0.9, minus 450x plus 1,000x, 0.1 times 10,000, plus 1,000x minus 0.01 times this is 50, and they both have the x on it, so minus 50x squared. Let's rewrite that in a form we're used to seeing trinomials. So minus 50, let's lead with the x squared term. Combine these to get the x, which will be plus 550x and plus 9,000. Okay, now that's revenue, right? Now we can't just get rid of the minus 50. This is not equal to 0. This is equal to r. So, what do we want to do? Well, we need to find the vertex of this. The vertex is the maximum or minimum point. Since there's a minus here, we know it opens down and has a maximum point. That'll be the maximum revenue. Complete the square. Negative 50. Factor it out. X squared. Divide this by negative 50, right? It's going to give you minus 11x. Leave some space. And then we've got the plus 9,000. I'm only doing this the one way, okay? You can do it the other way if you like, but I've got to find my cursor. Okay, so negative 50 x, half of 11, right? So it's going to be minus 11 halves. Now, seeing as this is a real, thing. We're working with numbers, and we can use decimals on this. So x minus 5.5 squared. 5.5 squared is 30.25. So plus 30.25. So you say, you just added 30.25. No, I didn't. I added minus 50. I really subtracted 50 times 30.25, which is 1512.50. I just subtracted 1,512 and 50. So I'm going to add 1512.50. So that this line, this whole line, will be the same as the line above, this line. Okay, and what do? We just combine these two guys down here, and we go plus 10512.50. I have a maximum revenue of 10512.50, which isn't really what it asked. It asked for the price. And when x is 5.5, what is x? It's the number of 10-cent price increases. I need to make 5.5 10-cent price increases. Okay, let's make note of that somewhere. So maximum R value of dollars, $10,512.50 when x equals 5.5. Okay, that's 5.5 price increases. What's my price? Well, really, that's over here, right? This is the price, the cost. It's the price. So price is 0.90 plus 0.10 times 5.5, squeeze, which is equal to 1.45. Okay, so the maximum revenue of the, let's summarize, the max revenue of $10,512.50 was achieved with a price of $1.45. Okay, there we go. Sketching inequalities. Sketch the graph of 3x minus 2y is greater than 8 using slope and y-intercept. Okay, so we need to take 3x minus 2y is greater than 8. And I need to write that in y equals form, right? Or in this case, y is greater than y is less than form. So let's go negative 2y. We need to get rid of the 3x. Is greater than negative 3x plus 8. Y, divide by negative 2. When we divide an inequality, we must flip the inequality. Divide by negative 2, this will be 3/2 x. 8 divided by negative 2 is 4. So the line we're looking for is 3/2 x minus 4. How do we graph that? Find the y-intercept, which is negative 4. This is slope y-intercept. Slope is 3/2. Go up 3, right 2. There's a point. Go up 3, right 2, 1, 2. There's a point. Right up 3, right 2. There's a point. And I like to also go down 3, left 2, there's a point. I now have all the points that I could want on that line. Strictly less than, dashed line, arrows, because it continues on in both directions, so don't forget the arrows. Y is less than, so all the y values will be below this line. And so I'm not going to go with the highlighter. I'm just going to shade this in. So we're shading this. Dashed line or broken line tells us does not include any of the points that are on the line, but any point that's below the line works. Okay, what if you do this with x and y intercepts and a test point? So x-intercept, what have we got? Our equation, 3x minus 2y is, in this case, we're going to graph equal to 8 because I want to graph the line. So we say 3x equals 8, right? Make y 0 to find the x-intercepts. X is 8/3. And we say negative 2y equals 8. Set x to 0 to find the y-intercept. Y equals negative 4. got the negative 4. 8/3, that's really ugly to try and graph that, right? I mean, if it was a half, that would be okay. So we're kind of guessing that this is the point. We're going to sketch a straight line through those points. We're going to draw arrows on both ends because we hate losing half marks for that. Okay, but where do we shade now, right? We've drawn equals, and although we found equals, we know that since it's strictly greater than, that it will be a dashed line. And so I'm going to try the point 0, 0. I need a test point. How about 0, 0? Is 0, 0 in the region? Okay, well, let's find out. Go back up here. So test point. I always like 0, 0, right? I mean, either it is or it isn't. So test point of 0, 0. In the inequality, 3 times 0 minus 2 times 0 is greater than 8. 0 is greater than 8. That is false. This point is not in the region. This point is above, so we must be shading below, which I'm sure comes as a huge shock to all of us. Given a choice in this one, if it didn't say to graph by a particular method, I would be using slope-intercept, right? It's better. It gives you directly this. Now, if you're not sure, right, if you didn't know to flip this inequality again, you can try a test point just for the heck of it. You throw 0, 0 in here. If you're thinking of shading above, toss in 0, 0, and you'll say, oh, wait, I'm not, which will say to you, oh, maybe I forgot to flip the inequality sign here. Okay, last one. Holy geez, half an hour here. All right, but this is the very careful going through of these questions, right? Explaining absolutely everything. Determine the inequality the graph represents. We have a line randomly drawn. We have a parabola. Parabolas have equations of the form. We know the vertex, right? It's here. It's at 3, -5. 3, -5. That's P and Q. We have a point on the graph here. We're going to use that, right? So let's start off. I'm just going to write ax minus 3 squared minus 5, right? That's P and Q. Let's put in the xy. In this case, x is 0, y is 2. 2 is equal to a. 0 minus 3 squared minus 5. Okay, add 5 to both sides. 7 is equal to 9a, and a is 7 over 9, right? Opens up. Positive. A opens up. It's not a line. It's a dashed line, right? So then it's strictly greater than or less than. We're shading below. So let's go y is less than, strictly less than, right? Since it is below. A, 7 over 9. X minus 3, quantity squared, minus 5. Okay? And that is it. 7 over 9, x minus 3, quantity squared, minus 5. Let's pop into Desmos, and let's try that over here. Y equals 7/9. 7 divided by 9. Kick over here a little bit. X minus 3, close brackets, squared, come out here, minus 5. Oh, wait, sorry, not equals. What was it? Y is less than. And here we are, shaded. Let's show points of interest. Points of interest. There's a point of interest, right? The y-intercept at 0, 2. There's our vertex at 3, -5. Here's some other points of interest, but they're not all that interesting in this case, right? We didn't care about the x-intercepts. But you can see we have a dashed line. We're shaded below. All is good. You could, of course, graph this on your graphing calculator and see something very similar. Okay, it was long. It wasn't long, it was very long, right? But it's gone through in great detail. So if you want to sit down and watch, you've already watched for half an hour. Good review, and see you at the test tomorrow.